Have you ever wondered what causes the beautiful shimmering lights in the sky known as auroras? Let's dive into the world of these fascinating natural phenomena that have captivated humans for centuries. There are two types of these bewitching lights: the aurora borealis, also known as the northern lights, and the aurora australis, or the southern lights. Both are equally enchanting, painting the sky with a ballet of colors. By the end of this video, you'll understand the science behind these mesmerizing light displays. At first glance, auroras may seem like magic, but they're actually the result of complex scientific processes. To understand auroras, we first need to look at the sun. Our star doesn't just provide us with warmth and light. It also constantly emits a stream of charged particles known as solar wind. This wind is a plasma, which is a state of matter that's neither solid, liquid, nor gas, but something entirely different. The particles in this plasma, mainly electrons and protons, are thrown out into space with such energy that they can reach the Earth. And when they do, they encounter our planet's magnetic field. This magnetic field, invisible to our eyes but instrumental to our survival, acts as a protective shield against these charged particles. But the Earth's magnetic field is not a solid wall. Rather, it's more like a fluid, bending and flexing under the influence of the solar wind. At the poles, where the magnetic field is strongest, some of these particles manage to slip through and collide with atoms and molecules in our atmosphere. These collisions excite the atoms, causing them to move to a higher energy state. But atoms prefer to be in a lower energy state, so they quickly release this energy in the form of light. And this, my friends, is what we see as an aurora. The variety of colors in the aurora depends on the type of gas in the atmosphere and the altitude at which the collision occurs. Now, solar wind is a continuous process, but sometimes the sun throws a tantrum and releases an enormous burst of charged particles. We call this a geomagnetic storm. When such a storm hits Earth, it can supercharge our magnetic field, causing a spectacular display of auroras, even at lower latitudes where they're usually not seen. So, the next time you see an aurora, you can appreciate not just its beauty, but also the incredible science that makes it possible. You might be wondering why auroras come in such a variety of colors. Well, the secret lies in the composition of our Earth's atmosphere and the altitude at which these awe-inspiring lights occur. Our atmosphere is a cocktail of various gases, with nitrogen and oxygen being the most abundant. When these gases interact with charged particles from the sun, they emit light of different colors. Oxygen molecules, for instance, produce a greenish yellow or red light, while nitrogen gives off blue or purple light. The altitude is also crucial. Lower altitude auroras, around 60 miles up, are typically green due to the presence of oxygen. However, as we move higher, say about 200 miles or so, the red, blue, and purple hues become more dominant because of the interaction with nitrogen. So, whether you see a green, red, blue, or purple aurora, you now know it's all down to the type of gas and the altitude. So, let's recap what we've learned today about auroras. Auroras, otherwise known as the northern or southern lights, are more than just spectacular light shows in the sky. These mystifying natural phenomena are the result of a complex process involving the Earth's magnetic field and atmosphere. At the heart of this process are charged particles from the sun, also known as solar wind. These particles are drawn towards the poles by our planet's magnetic field. Upon reaching the Earth's atmosphere, they collide with gas particles, a collision that triggers the captivating glow we recognize as an aurora. The color of the aurora is determined by the type of gas particle involved in the collision. Oxygen particles, for example, can produce green or red lights depending on their altitude, while nitrogen particles can create blue or purple lights. The specific color you see during an aurora event is a direct result of these atmospheric interactions. The formation of auroras is a testament to the dynamic and fascinating nature of our planet. It is a perfect example of how science and nature intertwine, creating phenomena that are not only visually stunning, but also scientifically intriguing. Thank you for joining us on this journey through the scientific marvel that is the aurora. Remember, science is everywhere, even in the night sky.